Hello, my name is Prahasdeep Singh, and I would be explaining about the code for the experiment number 2 of DSP lab, which basically implements the real-time signal of heart signal to calculate the and so we are required to calculate the heartbeats of the signal. So first I will be explaining the code part, and then we'll be seeing the results. So now moving on to the code part. The first line is basically the we call the metro library, and now first we will take the signal from first we will capture the signal from the sensor, and then we will perform some signal processing operations, which include a moving average filter operation, and then a derivative operation after we normalize the signal, and then we observe the peaks, and then we calculate the beat rate. So now moving on. So first, samples number of samples is defined as an unsigned integer having of 16 bits having value 150. Then mean samples equal to 10. This is basically the window size of our moving average filter. Sampling frequency equal to 50, so this is sampling frequency, and the double is the like its type, a variable type. Delay ms, so this is the delay. So delay is we define delay as 1000 divided by the sampling frequency, which is 50. So metro sampler equal to metro delay ms. This is basically what it does is it delays each time a frame of 150 samples comes. So it's a predefined instruction in the metro library. So it helps the Arduino board to know what for which time it has to delay for the next output next output frame, so that it is able to process data data. So now moving on. So PPG signal and PPG signal DCT are our two arrays. In PPG signal we will store the signal, and in PPG signal DCT will be performing some signal processing operations. Now moving on to the first step, void setup. So this code will be implemented only once. So in this code we will be initializing PPG signal and PPG signal DCT to 0, and we will be specifying the baud rate, which is set at 19,200 bits per second, and also we'll specifying the pin mode, which is A0 pin. We'll be taking the signal input from A0 pin. Now moving on to the loop part. This part would be implemented in loops, and it will run continuously or indefinitely. First we will define int i2 equal to 0 variable. So we would be storing the input values or real-time input values into our original signal, PPG signal, and we have chosen this -200 randomly. First this depends simply on the results. For 200 we were getting better results, so we set it at 200. And then moving on, moving average calculation. So this is here the uh, the samples minus me samples. So basically i3 is a variable. So like 10 windows, so when the window size is 10, mean sample is 10, so 10 windows would be selected, and its mean would be calculated and placed on the below array or the next array. So basically you can also store in the same array. So we can just up till 10 units we'll be calculating array of 2 and storing it in the second element, and then calculating the average of 5, then storing it in the fifth, then calculating the average of 10 and storing it in the 10, calculating of the next 10 elements and storing in the corresponding 10th element. So ith element, and storing the corresponding ith element. So basically this is a moving average filter, which was discussed in last video also. So Now moving on, now we have passed the signal to a moving average filter, so basically it reduces some high frequency noises. Now we will be removing the signal mean. So first we'll be calculating the signal mean by mean calculation, and then we'll be removing it from the signal. So now to calculate the mean, we define a temp variable equal to 0, and then we will be just be taking each element x1 by number of elements, so x1 by 150 plus x2 by 150 plus x3 by 150 up till x150 by 150. So this will give us the mean, which will store in temp var2. And to remove the mean, so we will be subtracting the mean from each element, and this will update our PPG signal. Now we are move on to the normalization stage. So in normalization stage, we will be calculating the absolute, first we will be calculating the absolute maximum value, which is of the whole of the data. So now we will describe, we will call one variable, temporary variable, max val1 equal to 0. So initially its value is 0, then it will store the next higher value, then the next higher value, and so on. So for like absolute part of a PPG signal, so even if the signal is negative, it would be storing its absolute value, and that value will be compared with the previous value, that is max val1, and the higher of the both would be stored in the max val1. So in this way we'd be able to calculate the max val1, which would be the highest highest valued element of the PPG signal. Now moving on, to normalize the signal, we would divide each signal element by that highest value, and this would give us the normalized PPG signal. Now after normalization, we would be calculating the derivative of the PPG signal to evaluate the heart rate or beat rate, heartbeat rate. So now we will initialize our PPG signal DCT to the initial signal. This for loop does it for us, and then we'll be calculating the derivative, which is essentially the difference of the two elements of the PPG signal and storing it in the PPG signal, and difference of the two ith minus 1th element of the PPG signal. Now moving on, mm, so here we will be calculating the peaks. So this code is actually similar from the last video. So it basically tells us that if PV signal is less than equal to 0, we'll be concluding that the signal would be equal to 0, and we'll be focusing on the highest point of the ith element. So if the ith element is greater than the I minus 1th element and is also greater than the I plus 1th element, that means it's the highest point in the curve and is also greater than a certain 0.01. So this is a pre-calculated value, theoretical value, and if it is greater, then we'll be storing that element as data only. Otherwise we'd be taking the element as pp signal dct I equal to 0. So only that signal value would remain, and rest would all be turned to 0. So if this is the peak, then our signal would be like this: high, then all 0 0 0, and then high, then all 0 0 0. So now moving on, so we will be calculating a threshold. So we notice that we are also evaluating the sum of each of the maximas. So we will be first calculating the sum and then dividing it by the number of maximas, so which will give us the threshold. So we will be considering all the signals that are above, all the maximas that are above this threshold for evaluation of the beats. So all the maximas would be considered, all of the such maximas would be considered. Now moving on to calculate the beats. So this is the part where we will be calculating the beats. And so in so now to calculate the beats, we would be storing the beats in a in a variable called distance, and we would be starting it from -1. So now we have all the peaks at in a ith positions. So we are basically required to select one I position as start, which would be do the work of start. So then we choose when we choose this position, we just look for the next peak, and then we store that position. So this position minus the start position gives us the distance, which is calculated over here. So essentially this is the code which just for that. um, it starts if start equal to I, if the pp signal we concluded that it is 0 for all the elements except at the peaks. So if it is not equal to 0, then our start would be defined, and else it wouldn't be defined. So our start would be defined at I, and then we would be able to calculate the distance. So now we have the distance between two peaks. So this would give us the peak, this would give us the beat rate. mm, and so distance equal to distance times flag minus 1. So flag was set to 0, and each time the peaks are evaluated, it is incremented to 1. So 1 2 peaks 1, there is it 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 adds to 1, then 2, then 3, as such. So basically gives the average of the distances, and this would be divided by 50, because 50 is our sampling frequency, and we would be multiplying the distance into 60 for, because we are required to calculate the heart rate at beats per minute. This would have given us the heart rate in beats per second. So now I'd be showing you the result. So now we'll be measuring the heartbeats. So to measure the heart rate, let's run the code. um, Let it upload. So we'll just monitor the heartbeats. So we can see the heartbeats are coming in the range 79 to 81, and so these are the results.